Hello Algebra 2 class. The very first day of class, we went over a method called the finite difference method. Now I want to go over this problem to kind of give you some more practice, especially those of you who were absent. This might be a good time for you to watch these videos and kind of get caught up. And the idea behind it is, let's say we have a table like this. Alright, so I'm going to write this down. Maybe the table looks something like this right here. So we have our x outputs right here. We have our, this is our inputs. This is our inputs, this is our outputs. Okay, so we have 0, 10, at 1, it's 9, at 2, we have 12, at 3, we have 19, at 4, we have 30, and at 5 we have 45. Okay, so what it is that first day we were trying to find patterns in this table. We were trying to see what kind of patterns we could find, and one of the strategies that we used is we took the difference to determine what that's going to be. So how it worked was we first kind of went about doing this. We did, what's 9 minus 10? So 9 minus 10. 9 minus 10 is negative 1. Now we're going to have 12 minus 9. And 12 minus 9, as you could imagine, is just going to be 3. Then we have 19 minus 12, which gives us 7. Then we're going to have 30 minus 19, which gives us 11. And then 45 minus 30, which gives us 15. So in this problem here, we recognize that we're basically doing 9 minus 10, 12 minus 9, 19 minus 12, 30 minus 19. So we're subtracting. We always take our second input and we subtract it by the previous one. Then we take this input, which is 12, is subtracted by 9. Now we get to this problem here where we don't find a pattern. We haven't determined yet what it is. And remember that when we do our finite differences, this is our finite differences of first degree, D1, which means that we took our first finite difference, but we don't have a constant rate of change. It doesn't change constantly. So we want to continue to do the method. So we're going to continue. Well, what's 3? What's 3 minus negative 1? Well, that's 4. What's 7 minus 3? Well, that's just 4. What's 11 minus 7? That's 4. What's 15 minus 11? That's 4. After we took the second difference now, difference 2, we recognize now that we have our constant rate of change. And so basically the idea behind it that we learned in class, or for those of you who had practices, it took us our second difference to get a constant rate of change. So if it took us a second difference, it took us D2, that means that our polynomial, our equation, is degree 2. So that means now that our equation is going to look like this. Remember, by definition, degree 2 means that the highest exponent is 2. So we're going to have an equation that looks like this. If it's degree 2, it's going to be quadratic. And that means that the equation is going to look like y equals ax squared plus, we're going to subtract by 1 on the exponents, ax squared plus bx plus c, x to the 0. This is a 1 here. Remember, 2 subtract 1 is 1. 1 subtract 1 is 0. But anything raised to the 0 power is just 1. So we get this equation right there. So that's basically what the finite difference method was. Now I'm going to go ahead and go over maybe a little bit more complex problem.